How have you been? Great to see you again. Hey, Emil. Good
I
to see
am
you.
doing great.
Jerry.
Hey, what's up, guys?
Hey,
Jerry, did you
Hey
find a good
everyone.
place are you still outdoors or are you
No,
in?
I'm good. I found
Yeah,
a
you're
found a
good.
spot.
Hey,
Yeah.
Tallat, great to see you. Great to see all of you. Did you guys see the the poll? So we had this poll, what things should not be automated, right? So this was a good one. I will not play it in full screen, but you guys can actually take a look at this, right? So people are actually worried that relationships are going to be automated, right? So relationships, healthcare, emotions, deportation decisions, and
Well, as
all
a
of that.
graph guy, I have to say that you can automate the creation of some relationships in data.
Yeah, absolutely, absolutely.
somebody says wedding proposal.
Wedding, I don't know. I mean, why would anyone actually automate a wedding proposal, right? So
What can I
Yeah,
say? That sounds
and
awesome. That sounds
yeah,
great. I
uh,
would
and
take that in a
automated.
heartbeat.
I mean, yeah, automated, and then yeah, maybe if there's an agent on the other end as well. I mean, I don't know what's going to happen.
depends who you're gonna marry.
Yeah. So we are going to go ahead and get started. Thanks everyone for joining. We are going to go ahead and get started. And this is, I've been looking forward to actually talking to all of you in the same panel. So we'll go ahead and get started. Bob, Emil, Jerry, and Talat, I mean, thank you so much for being here. We actually had more than 51,000 RSVPs for the conference. I mean, we had just a lot of response, and even now we have a lot of people actually who are joining live. So let's get started. So let's go around, and then what I'm going to do here is maybe you can very quick introduction of yourself, and then perhaps if you can maybe add this with, I mean, your own introduction, the company, what do you do, and then maybe something unusual, surprising insight about context and retrieval that most people don't realize that it maybe the importance of it, or maybe any complexity, anything that you would like to choose. So, Bob, you want to go ahead and get started?
Yeah, sure. Right now, or are we
Yeah,
good to
we
go?
are live.
All right,
Let's go ahead and
wonderful.
get
Oh,
started.
we're live. Fantastic. Well, hello everybody.
Yeah.
So my name is Bob. I am one of the co-founders of Weaviate. That's an open source AI native database. So something about context windows. Well, it's a context window is just a big array of vector embeddings. So and if we store something, if we want to store and retrieve something, we need a database management system for that. So working with vector embeddings, regardless if it's inside or outside of the context window, is something that I'm interested in.
Thank you. Emma, you want to go ahead?
Sure. So my name is Emil Eifrem. I'm one of the founders and the CEO of Neo4j, which is a graph database. I'm going to claim it's the OG graph database, or at least we've been around for a while now, and seeing a surge of adoption related to kind of the marriage of graphs and AI. A surprising insight about context retrieval. I'm not sure if it's surprising, but it certainly has surprised me that there's a lot of focus still, like years, like whatever, 2 years into this, on kind of unstructured only content. And it seems like kind of that default thing of chatting with your PDFs still seem to be like too prominent of a concept in people's minds. And at least the use cases that we see, it's actually mixed data. It's a combination of structured data with that unstructured data. Some people call it semi-structured data. I'm a little bit geeky about definitions with data. So I tend to call it mixed data. So you have structured data with some long form kind of unstructured text fields, typically text fields in them. And I think that's kind of the core data that at least we see people most typically use in real use cases.
Thank you, Emil. Jerry, you want to go ahead?
Yeah. Hey everyone. Jerry, co-founder CEO of LlamaIndex. You might have seen us as like a RAG framework, from 2 years ago. Since then, we've evolved our mission. Our mission now is basically automating document workflows with AI agents. I basically agree with everything Bob and Emil said. Maybe just two quick follow-ups. One is I think the quality of your context does matter. A lot of these days we spend time kind of working with customers on just like really complex documents and document understanding use cases and the set of operations you do on top of them, whether it's converting them to Markdown for RAG purposes or extraction into some downstream workflow. That initial step is super important because if you actually get that step wrong, you basically get hallucinated results down the road. And so a lot of the work that we've done is basically on the document parsing extraction side. Number two, and this is kind of specific, but it's just something that we've been thinking about, and we might do a release on this next week at the AI and World Fair, is basically like the Excel is like I've said this before, like a pretty degenerate format. And I think a lot of what you can actually do with Excel is instead of like trying to think of it as a RAG problem, think about it as like an agent with tools. And so just think about it as like an agent being able to write code or kind of like being able to write a set of operations to basically retrieve and transform the results that you want. And so, yeah, we have some cool stuff around there, but passing it over to Tallat.
Thank you, Jerry. Hello? Tallat, we cannot hear you.
Can you hear me now?
Yes, we can.
Yeah, okay. Yeah, sorry. Hi, everyone. I'm Tallat from Vectara. I'm one of the co-founders, and we have a RAG platform that's end-to-end SaaS on-prem and also agentic framework. So coming to the question, what has been said already, I 100% agree with that. These days it's hard to get surprised, but I think the one thing we noticed from our customers is basically when they try things out, they take retrieval as good enough is okay. But once you go to productionize, good enough is not okay, because anything like when your retrieval is not good, it has very like strong implications on the end results that you're getting from the outside. So at that point, they realize that good enough is not actually good enough. So at that point, retrieval becomes a very core part of any agentic workflow that you want to do. So.
Okay. Thank you, Tallat. And I will go last. Iqbal, Chief Data Scientist and founder at Data Science Dojo. And one thing that I found actually quite surprising is that even people who are, practicing software developers and, people who should be understanding this fact, they cannot differentiate between a large language model and an application like ChatGPT, right? So, wouldn't GPT-4o know? So I mean, it's almost like ChatGPT and any model that comes out of OpenAI. ChatGPT and all the models are interchangeable, and that's where you have to explain to them that context is everything, right? So without context, even the best and the most cutting-edge model is actually, it's not as useful. So we'll go ahead and get the discussion started. Bob, is it okay if I start with you? Right? Can we go ahead and get started? Yeah. Okay. So
Yeah,
Bob,
sure.
question for you, right? So generally speaking, I think we have set the context. So why is a retrieval system important in Agentic AI, and how does a vector database help bring context to an application? Because I mean, I see all these posts, RAG is dead. And this just yesterday, and I'm not exaggerating, I saw vector databases are dead, right?
Yeah.
I saw that. I said, I mean, I will tell Bob, vector databases are dead, then time to move on to something else, right? So Bob, please go ahead.
Yeah, I saw that too. It was funny that post used the SDP. They used the German Deutsche Bahn as a as a visual for that, which I didn't understand that relation. No, it's super interesting to see that. I think that I mean those kind of things are also a little bit clickbaity, but just that give people the benefit of the doubt of what they are what they're arguing, right? So the argument that's often being made is the context window is so large now that we don't need an external storage engine to store external information. So first of all, I think what's also very important to bear in mind that to do RAG, you don't need a vector database per se. It just solves a very specific problem. So right, so I'll share in a bit what that is. But that's the argument that is often being made. So context window is so large that we just stuff everything in the context window and the problem is solved. Now, what's very interesting, if you just double click on that and you start to think about it, is that let's say that we would do that, right? And let's say, for the sake of argument, that we would have from a speed perspective and those kind of things, we would be happy with the results that come out of that. We still want to store that information. So if I talk about something and I store that in the context window, I somehow need to, well, store that information. Storing information in a digital system is just what we refer to as a database management system. So a larger context window does not solve the problem of needing to store that information somewhere. Secondly, and I always like to refer back to the original RAG paper. I mean, it's literally in the abbreviation, right? It is when you do generation, when you generate something, you augment the context window by retrieving something. So if you have a use case where you have, let's say, I don't know, a random number, 10 million data objects that you want to search for, the argument that's being made in the research paper is, rather than somehow stuffing that in the context window, just offload it and only use the relevant information that you need. Now, so it's kind of, so the argument that's being made, I understand the argument that's being made. So the argument that's being made is like, context window is so large, you don't need an external storage engine anymore. Well, to do that, you need an external storage engine, right? So it's like it's just like a circular reasoning thingy. Now, talking about specifically database like Weaviate, the reason that that we, for example, say that we believe that the database like Weaviate so nicely fits with RAG has nothing to do with that it's vector embeddings and that vector embeddings are related to machine learning. No, it has to do that the query that's going in is very often very ambiguous, right? So that's the nice thing. So basically, I don't want to put words in your mouth, Emil, but I could imagine that an argument where you would make like, hey, if you want to start the discovery in a graph, or in our case, if you want to start the discovery in documents that you've stored, you start from the perspective of an ambiguous query. And that is the powerful thing, right? So if you're gonna put stuff in that context window, but the query is ambiguous, then you need to start somewhere. And that's why for semantic search or vector-based search, or in our case, most of our customers use actually hybrid search, works so well. So it's a very long answer, but to quickly recap it. So it's like the argument of like the larger context window doesn't need an external source because it's now so large. That goes against what exactly is described in the RAG paper. It basically describes, no, it's great to have a large context window, or they get larger and larger, but we want to have an external data source where we retrieve stuff from to be efficient and to store data back into. So that's the argument, basically.
Sure. So thanks for a very detailed answer, Bob. We use hybrid search, and then we get both the keyword side of it and the semantic side of the context that we're bringing in. But recently we have been seeing that you need a knowledge graph to augment or maybe overcome some of the shortcomings that your context has, even if you're bringing it using a semantic search or a keyword search or a hybrid search. So Emil, can you give us a very layperson's explanation of why after hybrid search you would still, or you might still need a knowledge graph?
Yeah, so we see 3 drivers when we look at kind of people choosing to use Neo4j as part of these types of applications. It's accuracy, it's development productivity, and it's explainability. So I'll double click briefly on each of the 3. I think accuracy is maybe the most intuitive one. Like, I don't know, maybe, but I feel like we've run a massive RAG case study, like humanity has, over the last, whatever, couple of decades, right? Which is called the web, right? And some of us were around back then, some of us were not, but like back when, like in the late 90s, when I started going out on the internet, like Alta Vista was king of the world. And some of you might be Googling what AltaVista is right now, but that's a search engine kind of pre-Google. And the problem AltaVista had was the AltaVista effect, which is basically you search for something and you got so many hits, and the real one was like on page 38 or something like that. So you flip through a bunch of these things. That's what the world looked like kind of pre-Google, right? And AltaVista used basically inverted index, BM25-like type search, right? And then Google came along and said, hey, I'm going to do that. I'm going to search inside of each document, right? But I'm also going to rank it based on the links. So page rank, right? Which is a graph algorithm called actually eigenvector centrality. But it doesn't matter what it's called. But basically use kind of the graph to rank and find the top 10, like the top 10 blue links kind of thing. And all of a sudden, we all found like the answer in the first page, right? The first top 10 links, right? It turns out that the quality of your RAG application is directly proportional to what of the documents that you get out of the RAG corpus, like your hundreds of thousands. What was your example, Bob? Like 10 million kind of objects, right? So which are the top 10 that you choose? I just choose 10, like top n, small n, right? And so I think there's some precedence that using the signal of how things fit together gives you higher accuracy. And there's now been a ton of research kind of proving that out. And this is not instead of vector search, it's in combination, right? And this is like, so for example, Weaviate and Neo4j, we do a ton of work together, right? Like if you go to our blogs and you'll see that. It's like, okay, stand up Weaviate, use that for the vector search, stand up Neo4j, use that for a knowledge graph. That's really powerful. Kind of like, we're not next to each other right now, but like Bob and I would be doing like, that thing, right? Like the heart little thing, right? Right, Bob? Yeah. That kind of thing, right? And so that's the first one, accuracy. And then I think the second one is, okay, what's nice about graph space compared to vector space, right? Vector space is very opaque for a human being, right? It's very just binary, right? Graph space is like, okay, you have a thing and it's connected to another thing. It's like, I'm a user which is connected to a support article and other users have voted on that. Like, it's explicit, you can touch it, you can feel it. And so when developers build applications, once they've created the graph, that's the big stumbling block for graphs. Like, how do you create the graph, right? But once you have the graph, right, then developers love the fact that they can see the information, right? And that gives us also the third benefit, like the explainability piece, which we sell into like all the big banks of the world and like government and that kind of stuff, right? And they love the fact that they can understand, like they can follow along in the graph and understand why did they choose these top 10 or top 20 documents. It's because they visually navigated in this way. So that explainability is like the third benefit. So those are kind of the three drivers that we see: accuracy, developer productivity, and then explainability.
Thank you, Emil. So I will use your and Emil's answer as a segue, and then build on top of it. So now that we have the context, whether it is coming from vector or not a vector, any other source, right? Could be search, could be a SQL database, could be anything really, or for that matter, a knowledge graph or graph database. Now, is that enough, right? So because there's more to it, right? So once you have all of this context, you are going to actually do some reasoning and planning on top of it, right? So Jerry, you have been a leading framework in industry for a long time, and now you mentioned that you're working on this more a general purpose document processing framework. So can you tell us a little bit about why is reasoning and planning actually important in all of this? I mean, why can't we simply get the context and hey?
Yeah. I mean, I guess reasoning and planning are kind of core fundamentals of like an AI agent, right? I guess you could argue if you didn't have reasoning and planning, it would just be like a one-shot LLM call. No, I think it's a good question though, and I would just like slightly reframe it to basically what are some general like architectures that you want to use reasoning and planning for different types of use cases. We talked a lot about like context and storage, and I think Emil and Bob have a lot of experience on like the fundamental like I guess data models and underlying like storage systems to basically represent this massive amount of context. In terms of reasoning on top of enterprise data, I've seen a spectrum of basically like applications ranging from things are a little bit more constrained to things that are a little bit more unconstrained. And what I mean by that is, like, you can either have constrained reasoning architectures where you basically do like step 1, then step 2, and step 3. And those are typically better for things where you need to automate like an end-to-end business process, and it needs to be somewhat predictable and reliable. And so, for instance, like some of the use cases that we're working with include like, data sheet extraction or like invoice processing and reconciliation. Those are basically like business processes that, typically a human might have to do in terms of like a rote or a routine operational task. And you can basically codify as part of an agentic workflow, but you don't really want that agentic workflow to do like basically arbitrary things. You just wanted to solve that task and solve it well, because if you do that well, you already provide a ton of efficiency gains to the end user. And usually to make it like a little bit more agentic and multi-step, it helps to have the confidence that this thing is going to work relatively well. And so you define the parameters of the agent such that you maybe give it access to one tool in stage 1, and then in step 2, it has to like do this other thing. And then step 3, it has to do this other thing. So you basically have pockets of non-determinism to basically reason over unstructured data, but it's kind of wrapped in this overall deterministic architecture. We have an overall agent orchestration framework that helps developers basically build these types of constrained workflows, starting with that. And then I've seen that those types of workflows typically work better for like these kind of more end-to-end business process automation use cases. On the other end, you can basically have something that's a little bit more unconstrained. And what I mean by this is basically like a general like React agent or an agent that can write code with like a set of diverse tools. And for those, I typically, there's usually a trade-off between like how broad you make it, as well as like how much human in the loop needs to happen. Because usually like the more tools you give to the agent, the more human in the loop you need to introduce. And that's how you get to these like chat assistants, where maybe it is an agent with access like, and different tools, but you really need the human in every stage of the process to really guide the agent. And those types of use cases tend to be a little bit more for information gathering and then surfacing the information back to the user, and less on kind of end-to-end automation of the decision making. And so I see a spectrum between the two. Like I call the former one like automation-based UXs, the latter one kind of assistant-based UXs. And the core architecture pattern is either like a constrained workflow or unconstrained workflow. And these are different ways that you can basically kind of make use or interact with the context from your enterprise data. The former one's more given a data, achieve a certain task in a routine way. The latter one's more, work with the user to do like information discovery, chat, so on and so forth, right? Like the standard patterns people are used to with ChatGPT.
Yeah, thanks, Jerry. So Tallat, coming to you, right? So a lot of these vector databases, a lot of these frameworks, reasoning and planning frameworks, they are available in open source, right? So I mean, any decent dev can just go and clone these repositories and get started, right? So why do we have, you are working for Vectara, you're the founder of Vectara, actually. Glean is there, Copilot, Amazon has products, right? So and all of that. So what is it that these companies that do for enterprise? That, I mean, why can't I just go? I mean, if I'm a decent dev, I should be able to just clone this repository here, that repository there. What does it really take to build an agentic AI system, or generally a RAG platform that I cannot build myself? I mean, what is the value add? I mean, how do you build? What are the complexities involved in building a system like this?
Yeah, thanks. That's actually the premise of the whole company, basically. I think the biggest thing we're seeing is that even some of our customers, they exactly said what you said. I can go off the shelf, take this, take that, and do this myself, including models, because we have our own models as well, right? But doing something as a prototype is very different than going to production. Okay, some of those production things Emil already mentioned, like even adding traceability, where you can explain why did this result come back like this, right? So doing production at scale requires way more than what you need for a prototype. A prototype you can build very quickly today. You can even use agentic coding to build a prototype for you. We had customers who did not sign up with us. They went away, they built their own stuff, and then 3 months later they came back, right? So there's stuff like scaling, but there are also small features that are missing from some of these out-of-the-box options, right? For example, one of the customers, they wanted list-based filtering, okay, for their vector search. And the stuff they were using out of the box did not have that. Another customer wanted to integrate with their LDAP. A third one wanted UDFs, user-defined functions, to apply when they wanted to re-rank their results. So there are a lot of features that are missing out there. Maybe 5 years later, a lot of these things, when they settle down, the open source and all that kind of stuff will have those features. But still, when you go to production, you still need a lot of additional handholding. There's even security, right? Like how do you ensure that this deployment actually is secure? Then come the hyperscalers, right? Like you can go to Google, you can go to Microsoft. Another trend we're seeing is that a lot of companies, they do not want to send their data to the cloud. A ton of this data is actually very confidential, right? So they want their applications run inside their own data centers. That's why like a lot of companies, they provide on-prem solutions as well, and that's what we are doing as well, where we don't even have access to the deployment anymore. Like they will switch off the access to the internet to that particular application, and then just access it within the company. And then when you talk about companies like Glean, they are one layer above us, basically, which means that they are an application. At their core, they could actually use us to build what they're building. So we focus heavily on how to build a platform exposing APIs to do RAG well, to do agentic well. We have a lot of emphasis on just the R part, basically, the retrieval part, how to do that well, because that's, like everybody's saying here, the context you give to the LLM, the generate the final answer matters a lot. And most of these companies, they have millions of documents. You cannot throw everything there. If you want to do a small demo with one PDF, they will work very well. You can put that on as a context, but apart from that, it's not gonna go far. And then comes expertise, right? Like you need multiple components to build this. You need to be good at prompt engineering. You need to be a good backend engineer. You need to be a good machine learning engineer to know which models can be used in what part, right? You need to be a good product person as well. So do you really want to have 50 people here to do this basic thing? At the end, it's going to cost you way more than a company that does this, like that's their bread and butter. So that's I think the value gets added by companies like us.
Okay. Thank you, Tallat. So my next question is going to be, I mean, any of you, I mean, feel free to, jump in. The model context protocol. So, that's there's a lot of buzz around MCP at the moment. So can one of you actually just explain what problem does MCP solve, and for someone who does not quite understand everything, but they just a beginner in LLM applications?
Yeah.
What problem does MCP solve?
I can take that one. So it's easiest to explain based on an example, I think. Right. So we have a customer that's an email client, and if I use the RAG functionality that they have over my emails, and I ask, for example, flight. So it's like, what time does my flight leave today? It does very well. So it gives me the exact answer that it says, like, your flight is leaving at 2 p.m. from there and there. If I now ask the follow-up question and I say, which terminal is that? The problem is that information does not sit in the email. So it can't answer the question because it can't retrieve more information from that email. So what you can do with MCP is that there's probably an MCP server that takes care of, like, departing flights and arriving flights and that kind of stuff. So it can basically ask, well, for this flight that is departing at this time from this airport, what's the gate? And then it retrieves that information and sends it back. So what you start to see is like a whole network, like a knowledge network, if you will, a knowledge graph. But the whole,
I'm sorry, there's another word. There's a synonym for network, Bob.
yeah, yeah. I said it, and I was like, I'm waiting for him to
Emil, the
step
word
in.
knowledge is
Yeah,
your trigger. You start smiling the moment
I
somebody
can do this all
mentions
day.
knowledge, right? So
exactly. So and the and so we can extend that with more knowledge, and that's basically what it solves. So it's like a think about it. You know, if you're at home, you're cooking something, and you go like, oh, what's the recipe again? You take a book and you look in the book what the recipe is. Well, MCP is basically just, you know, an encyclopedia of information that your system can tap into. And because it's generic, you know, we can just connect them all together. So that's how I look at it.
So just to add to what Bob said, I think that's very good. But let me go 10,000 feet even higher, right? I think LLMs, the natural input for them is natural language, right? You say stuff in natural. On the other hand, you have systems that are exposed through APIs, right? So now how do you make these two connect to each other? Their input is completely different, right? So MCP basically solves that problem. How do you make LLMs talk to APIs? So all you do is like you wrap your APIs around the MCP server, let's say, and then now all of a sudden these LLMs, they know about MCP because that's a well-defined protocol that all these LLMs are supposed to understand, and that gives them the power to know that, okay, fine, for this, I need to call this MCP server, which knows these parameters, so let me add those, and that's it. So it's basically like a interoperability way between natural language LLMs to understand and anything else that uses APIs, basically. So.
So we have so many. So Jerry, you wanted to add something?
Yeah, sure. I mean, I agree with everything that was said. Let's see. The only things I add is this idea of like an agent calling like tools that's not really like a new idea. If you've been around like 2 years ago when like these frameworks first started and like LLM started introducing like function calling capabilities, people were already doing this. The main benefit of a protocol is it's something that everybody can agree on as a standardized interface. And so therefore, you don't need to do the work of reinventing that interface for every new application that you build. And also there's interoperability with existing tools like Claude and Cursor. And so, you know, these days, the nice thing about MCP is that if you built like an MCP server, it'd basically be out of the box compatible with your ChatGPT, Claude, Cursor, whatever agent front end that you use. And also, you know, if you were to build like a AI agent on the client side, it'd also be interoperable without you having to figure out the interfaces with a bunch of the predefined MCP servers. So really, it's a nice way to basically standardize how agents interact with the external world. And I think to Bob's point, I mean, I think a lot of like us, like the kind of like overall theme around these like vendors is basically how you like store and index a lot of like enterprise context. And in the context of agents and MCP, you can kind of think about it as just like MCP servers that provide agents with, you know, context grounded on enterprise data, right? So it's really like a generalization of this idea of RAG. Agents being able to reason with these external services that can store and index large knowledge collections and let you take actions over it.
Yeah. So thanks, Jerry. So your enterprise data can be in a lot of different systems, right? So I can have my Salesforce, I can have my SQL Server, Neo4j, Weaviate, right? So I can have so many different data stores. So who creates these MCP servers? I mean, where do I get this MCP server, right? So, you know, do I write MCP server for each of them? How does it work?
That's a good question. Maybe I'll quickly answer this. I'm actually kind of curious to hear Emil, Bob, and Tallat's thoughts. I do think every SaaS vendor is going to create their own MCP servers in some way. Like Salesforce, SAP, every B2B SaaS out there is going to create some like servers. So basically, you know, as long as there's some sort of like system of record where they're storing some sort of data, then it makes sense to basically offer that up as an endpoint to basically plug into your AI agent. Of course, there's some like, you know, tricky parts right now with auth, like data privacy, all that stuff. I'm sure, you know, that'll be figured out in the medium term. I think one of the benefits I see though of still like, you know, being able to index context and kind of put it into a database is depending on how you actually structure and format the data, you can really like be able to analyze it in different ways. And I think that's why, you know, graph, vector, and general retrieval interfaces are so important. because these vendors will be able to provide access to their systems to look up like specific piece of information. But sometimes you do want to index like a knowledge base across your entire enterprise collection. You do want to create like an ontology from it. You might want to create a SQL collection from it too. And so I think like these data systems are so important in being able to give the AI agent like a different view of that data. But yeah, curious to hear other people's thoughts.
Yeah, I guess there are two things there, right? Like one is where do all these kind of MCP endpoints come from? I completely agree. I think all the vendors will do that. The SaaS vendors, we have one. Everyone will have like an MCP endpoint.
I
That
think
seems right to me.
Weaviate and Neo4j both have an MCP server officially.
Yeah, that's right.
Already, right? Yeah.
Yes.
And I think some of this is like when I look at MCP, like I almost think back to like the early days of HTML. This is like the value of an underspecified protocol, because like it is so amazing and it's so not amazing sometimes. You look at it, it's like really easy to throw up, get like an MCP server, and there's a ton of stuff that's not like they didn't want to think of security, they didn't want to think of identity, there's like a ton of things that haven't been done yet. But I think that's part of why we just saw this explosion kind of MCP kind of endpoints out there. I think the second thing that you said, Jerry, I think is super interesting, and I think there's this big, I mean, maybe I'll dramatize, like this big battle to be played out over the next several years, where I don't think we know yet which layer is the integration of all these data sources going to happen, right? Because we've spent 15, 20 years right now since the early days of Hadoop. Yes, there were like kind of data warehouses before, but let's kind of start from that point of view, where we've said, okay, we're going to grab all the data out of the big systems of records inside of the enterprise. We're going to shove it into like initially Hadoop and then Spark and then whatever your modern data platform was, Snowflake or Databricks or something like that, right? And that's going to be how you get this consolidated view across of all your data, right? Now we're starting to see this other vision emerge where it's like, you know what? I actually don't need to take it all out of these systems and shove it into one single kind of data platform, be it Weaviate, be it Neo4j, be it Snowflake, or like anything like that, right? My agents can just sit on top of it, and the main integration is happening at the application layer rather in the data layer, right? And that would be like, I call it the Salesforce kind of argument or the ServiceNow argument, or something like that, right? And then of course the data vendors, myself included, right? Like, and Snowflake and Databricks, like, no, it's way better to do it in the data layer. And it's unclear to me how that's going to unfold. Like, it'll never be 100% in either. Like, we're going to end up doing both. Is there an 80-20 here, right? Where like actually kind of proportionally more of that, like kind of that influence is going to shift away from the data layer of the stack. Obviously, I'm betting not, because that's where I sit, but it's actually not clear to me how it's going to play out. I'm not sure if other folks on the panel have any thoughts.
Well, so I don't know how it's going to play out either, but I think with looking forward, it might also be interesting
do you agree
to
with
look
the
at.
framing, like of that?
Yeah. So maybe I don't know, but so to think out loud here, I think it's super interesting also to look at it from a historic perspective, right? So just I'll try to get to an answer to your question, but based on historic perspective. So if you look at if you look at APIs, there was also when I started my career, the way to write an API was a RESTful architecture. And what's so interesting about RESTful architectures, for those who don't know, is that it's mostly about the language that we use, right? So for example, if you have like a RESTful endpoint, you use plural. So hey, you never say /customer, but you say /customers. Right, and then if you did a get on that endpoint, you got an array of customers, and if you did /customers / the ID of that one customer, you got one object. And so the RESTful architecture is very much about language. So how do we use language to explain to developers how to interact with the API? Now, I think what cannot be underestimated today with something like MCP, thanks to the models, is that a huge problem that we've had, like it just in general, like the world had, like in data, was that we needed a human to interpret the language that was in the API. So you could not have two APIs talk to each other, even if there was logical language in there. That then there always had to be a human in there to interpret it and to write it back. And the only thing that the RESTful architecture dictated to us was like how to write it that people would understand it. What we can do now is have the model understand the structure of the API based on the language that's in there. That's a revolutionary. We have never been able to do that. So we're quickly going over, okay, then we have MCP and then we interact with the APIs, great. But this was a problem that was like, it's unbelievable how large that problem was. And I think also relate, if you think about like the semantic web and those kind of things, how people, and I think, Emil, you know way more about it than I do, but how people disagreed on how to call things and how to define ontologies on the semantic web. And now we have a model that says like, you know what, I'll take care of it. That is unbelievable. So we removed the human in the loop there to connect these things together. So now trying to answer your question, I don't know on which level this will take place, but I think the fact that we now having models routing the traffic between these APIs without human intervention is just that's unbelievable. That was unthinkable even 4 years ago, 5 years ago. Not really answer your question, but yeah.
I think Raja, you're muted. So I think I agree with what has been said, especially like when Jerry said that all of these vendors are going to have their own MCP servers. 100% agree there. I think I'm older than Bob. Like when I started, there was this XML-based SOAP protocol where people were trying to specify everything in XML. Right now, the good thing is that with MCP, these LLMs can understand and call them automatically. So that's the big change that's happening. And lastly, like even if you look 6 months ago, people started to do federated search. Now, if you connect that to agents and what I said earlier, that companies have so much data, let's say in Salesforce, in Google Drive, Dropbox, this and that, right? They started asking, do we need to reindex everything and put it in a vector store or a keyword-based store or whatever, right? What happened instead was a lot of people moved to the direction of federated search as well, where you have a query that comes in, you send it out to these systems, you do the search themselves within their system, and now in your end on the agentic side, you're basically doing re-ranking. That, oh, I got results from Salesforce, I got results from Google Drive, got results from which one are the best results for this particular query, and let me do that too. So I think that's the direction that things are going to go. Everyone will have their MCP server, will very well define description, because that you need that for the LLM to know which tool to call when, and then even federated search was going to just be MCP based. So.
I love how we're dating ourselves based on the protocols. So
that's what I was thinking actually. Yeah, you can almost date yourself when you mention which technology you have worked on. So time flew by actually, so we did not have a lot of chance, and we are already toward the end of the session. So I'm going to actually direct a few questions here. So I'm looking at one question. This was okay. So these MCPs, so Amit Kumar, question, these MCPs will be hosted on which server? I think partly we answered that part, but example shared about flight terminal info. How will I get over the email? Basically, I queried, and now if I have to get that email, what would the flow look like? I think that probably that is the intent of the question. There's a lot of questions actually.
I think we're going to see an MCP server, which is an index of MCP servers. So that you just direct to one MCP server, and then you say, I want to know something about flight terminals, and then it says like, go over there to that MCP server. I would not be surprised if we start to chain these things together.
Yeah, and then you're basically reinventing a search engine at that point. But anyways, I agree with what Bob said.
And these are for the public MCP servers, right? Because definitely there are going to be some authenticated MCP servers, but more like a. So Bob, what you're envisioning is some kind of search engine or some kind of
No,
aggregator
so
of all the MCP servers that are public.
yeah, so I don't know. I'm going to assume that somebody's already working on this. But if you just keep brainstorming about this, let's say that you have a bank, right? So you can have an MCP server for your, I don't know, JP Morgan bank account, and then the MCP server tells you, well, this is the type of authentication that you need to bring to this MCP server to get access to it. Well, and so on and so forth. So that's what I meant, that you can keep chaining these things together. They just talk to each other, and then they say like, if you want to get information from me, this is what you got to bring. Think about credit card transactions, right? So if you have an MCP server and you want to buy something, it's like, well, this is how you need to bring your credit card information now, and so on and so forth. So it's like just a whole network graph of of MCP servers interacting with each other, and also telling each other how they want to authenticate, how you need to authenticate, what kind of information you need to bring, and so on and so forth. I would not be surprised if I now search for and now I feel old if I say Google, but search for an MCP index, then probably somebody's working on that.
So just to add to Bob, like what's happening today is that they call them tool registries. So you have MCP servers and they have tools, and then you register in this central service called a tool registry, and then your LLMs or whatever, they can go search over there. And that's exactly what Bob is talking about. It's in infancy basically, right? So it's gonna get much better than what it is today. The particular question here asked is about where they're gonna run. A lot of them today are just running locally. On custom, because a lot of agents are not running in the cloud. They run on your machine, like the agents that write code, they are on your machine, right? And people are not very comfortable either. The first version of MCP did not even have very good authentication and authorization mechanisms, right? Those are now changing. They move to the cloud. And in this email example, you can imagine that the SMTP server is replaced by a MCP server, right? So it's the same information that needs to flow in both directions. It's just that exposed through MCP. So.
Okay. Thank you, Tallat. There's one more question around how does this come into play? I mean, there is MCP, and then more recently, A2A has been also making waves. So how does MCP come into play, and with A2A, and what does the overall picture look like?
I don't know what A2A is. What is that?
The Google Agent to Agent
protocol.
Google's
Ah.
agent.
Yeah. I
Sorry,
mean, there's
Google.
conceptual differences. Yeah. No, I mean, there's conceptual differences, like MCP is agent to tool, so it's like a request response type thing. A2A is more like agent to agent, so theoretically you could have the agents pass messages back and forth. In reality, they're basically competing protocols, and so I think basically the roadmap's like the exact same for both of them. MCP is going to do more A2A stuff. A2A is going to do more MCP stuff. In the end, it's basically just whatever protocol is to use is the one that everyone agrees on. And so, you could just like sit back, watch, eat some popcorn, and see what makes sense, right? But I will say both of them seem reasonably big enough that they're here to stay.
So you consider them competing, not complementing?
I mean, they're not going to give you that as an official answer. But I do think, like, if you look at the roadmap, it's all kind of converging on the same thing, like authentication, doing like instead of request response, doing some sort of like back and forth message passing. I mean, I could see a world where they both coexist. I don't know if that's going to be the case.
Yeah. Sounds good. Any other thoughts on this, the Google Agent to Agent?
No, I 100% agree with what Jerry said. And Google recently announced that they accept the MCP protocol as well, right? So it's gonna be hard to see how MCP goes away in favor of A2A.
Yeah, sounds good. So generally, we have only 2 minutes remaining, maybe a minute and a half. So maybe I will go around the room. What are you most excited about, right? In terms of, I mean, whatever you're working on, what is it that you find most exciting in the context of, the agentic AI, or maybe retrieval context? Anything that you would like to mention?
I'll throw out two things. One is, we spent a lot of time talking about RAG and all that kind of stuff like 12 to 18 months ago. And at least for us, we saw a lot of experimentation, and we sell primarily into the enterprise. And honestly, up until end of last year, it was mostly kind of stuck in POC mode. People were like exploring and that kind of stuff. Holy crap, has that changed? You know how people say it's going to be the year of agent, it's going to be the year of AI in production. It's like, wait, because some Gregorian monks, thousands of years ago, like it's just going to shift on Jan 1st? Really? That's kind of what happened this time, right? So we see a ton of stuff moving into production right now in ways that it just didn't last year. So that's really cool. And then another thing I'm excited about is agentic memory. There's a lot of startups building agentic memory on graphs, and like I have a graph here of this, right? And there's we talked about MCP. MCP actually include a tiny little 300-person agentic memory, kind of in-memory graph, right? And so there seems to be a lot of kind of fit between graphs and agentic memory. So I'm really excited. But that's like where RAG was maybe in end of 23 or something like that. So those are two things.
Thank you, Emil. Anyone else?
I can go. So it's like I hope people don't mind that I'm gonna take a Weaviate example here, but we've released 3 database agents, so baked into the database, and one specific I want to highlight, and that's the transformation agent. And what you can basically do now is, in between your code and the Weaviate sits a transformation agent, and you can basically prompt it with things you wanted to do with your data. So it can update data, it can clean data, and those kind of things. And that is something that I'm extremely excited about. So these really baked in agents in the database. So that would be my answer.
Thank you, Bob. Jerry, Tallat?
Yeah, I guess it's kind of related to what Bob said. I'm excited about agents that can actually automate like the data ETL piece. I think I've actually mentioned this since like 2 years ago. But I think with the increased reasoning and just like extraction capabilities of agents, just automating data entry, processing, transformation end to end, and especially with the advent of MCP, kind of like what Emil and Bob said, you might actually have to do less data pre-processing for agent to actually get value out of it. And so just like how do you, there's like the entire modern data stack, like Databricks, DBT, Looker, whatever, you get a bunch of analytics of your data. How do you actually just automate the entire process from like, unstructured information connection to, the structuring of that data, getting insights end to end. We're kind of building some stuff in that direction, not all of it, but in general, I think that's a fun thing to think about because a lot of it relies on multi-step automation.
Thank you, Jerry.
Yeah, thanks. So I think I agree with the panel here, but just to add to that, I think the most stuff that I'm most excited about is the unknown, basically. The rate at which this field is moving is, my God, like I don't think I've seen anything like this, and that's what everybody's saying, right? Every morning you wake up, there's like something new, basically, right? Coming from here or there, some company or some different country or whatever, right? So that's the most
and crazy valuations as well, right? So
exactly,
yeah.
So the most exciting thing is the unknown. What's going to happen today? What's going to happen in 1 year from now? It's crazy, basically. So
yeah. Okay, well, we are 3 minutes over. So thank you so much, Bob, Emil, Jerry, and Tallat. Great having you.
Thank you.
Great to be here.
yeah, thanks.
That was wonderful. Thanks
Thanks, everyone.
Bye.
Cheers.